Welcome back, mathematicians. Another recap video for lesson 3.1. Today we'll take a look at the expansion of the products of algebraic expressions. To get warmed up for this topic, we will need to remember some things about area. Now, you might recall that area can be thought of as multiplying a figure's length by its width or its base multiplied by its height. So, let's get started. Let's say we wanted to find the area of rectangle A. If we had numbers, we would multiply them, but in this case, we have letters, so we're going to keep this in pure algebra mode. Stay with me. There's some pretty cool stuff that's about to unfold. Check this out. If we wanted to find the area of rectangle A, we would multiply whatever its length was by its height. How long is rectangle A? Well, we see that the length of rectangle B in blue has the same length of rectangle A. So we would multiply A times its height or width, which is x. Now, that would simply leave us with the expression ax or a times x because we dropped the multiplication sign. In algebra, whenever two letters are next to each other, it implies that you are multiplying those two quantities. All right, let's continue. What if we wanted to repeat that process for the blue one, the green one, and the yellow one? Let's jump in. The area of rectangle B would be A multiplied by its height, y. And we drop the multiplication symbol, and we could write that as A times y, or AY. And because multiplication is commutative, the order in which we write those terms doesn't matter. So if you wrote y times A, that would also be correct. Let's keep it moving. All right, let's continue on to C. If we wanted to find the area of C, what would we do? What math would we do? We would multiply the base B times its height, x. What about for D, the yellow? We would multiply the base B times its height, y. Then that would leave us with the expression xb or bx and the expression y times b or yb. Now, why do we need to know this? This is going to help us multiply any combination of polynomials. Now, that word might not mean much to you now, but by the end of this unit, it will. So, what can we conclude? Well, a couple things. First of all, what if we wanted to find the area of the entire rectangle? Just now we broke it up into 4 different areas. What if we wanted to find the whole thing? Well, we would multiply the entire height by the entire base. Now, what expression could we generate from that? We would get A plus B multiplied by x plus y. Now, check this out. Since the area of the large rectangle is made up of the area of A plus what else? The area of B added to the area of C added to the area of D, we can thus conclude, or we can conclude this, that A times B, that base, A times B, which is the base, I'm going to just call that B, is multiplied by the height, and that would give us the area, which is the same thing as doing what? Is taking all of these smaller components and adding them together. So, if we can wrap our minds around that, we're going to see some pretty exciting stuff. So, let's jump into some practice problems. We're going to start off with the area model, and then we'll try to move away from that and see if we can keep it in like pure algebra mode. Let's get started. All right, what if we wanted to start with this expression, y plus 1 times y plus 7? Well, let's call that y, and let's call this 1. Let's call this side y, and this 7. If we were to add y and 7, we would get the base of this rectangle. And if we were to add y and 1, we would get the height. And so very clearly we can see that if we wanted to find the area of the red, we would multiply y times y, which would give us y squared. If we wanted to find the area of the green, we would multiply the base times the height, which would be y multiplied by 7, giving us 7y. If we wanted to find the area of the blue, we would do y times 1, or just simply y. And if we wanted to find the area of the yellow, we would multiply 1 times 7, which would be 7. And if we wanted to find the entire rectangle, we would add all of these pieces together. So what would we add? We would add the red piece, y squared, to the green piece, 7y, to the blue piece, y, to the yellow piece, 7. Now, in this line of calculation, you might notice an opportunity to combine like terms. So let's go ahead and do that. We could combine 7y and y to get a total of 8y. And this is the expression. This is as far as we can go in terms of trying to simplify this expression. So pretty neat. So if it's helpful to see it kind of visually, you could go ahead and always do that. Let's try it again. This time, let's see here. Let's try, I guess, with the pure algebra mode. So I think I'm going to try that before we do another area model. Okay, so say we had the expression or the binomial. Bicycle has 2 wheels, so this has 2 terms inside the group, so that's why we call it a binomial. And we're going to multiply that by another polynomial of 2 terms, which we call a binomial, 7 plus y. Now check this out. Now this is the method that I'm going to recommend in class. The way that this one works is it's pretty simple to get the hang of, but check this out. You're going to take the first term, whatever the first term is in the first group, you're going to multiply it by the entire second group. So if you take a moment to just do the setup, this will be really helpful. We're going to do y times y plus 7. Now notice I'm just setting this up in this step. That's why I'm putting it in gray to show you what would happen in your head. But if you do it this way, there's a chance that you will make fewer mistakes. Next, you want to take the second term and multiply it also by the second binomial. That would mean we're going to take plus 1 and multiply it by y plus 7. Now, writing it in this format helps us to see that we're just setting up the distributive property. If we have a term outside of a set of parentheses, we're going to distribute that term to all of the items within the group. So let's go ahead and do that. If I multiply y times y, I get y squared. If I multiply or distribute y to 7, I get 7y. I continue that process here in the back. I'm going to distribute the 1 to both terms inside of my group. What does that result in? 1 distributed to y becomes 1y, or simply y. 1 distributed to positive 7 gives us plus 7. Opportunity to combine like terms. So let's go ahead and do that. We'll get y squared plus 8y plus 7. 2 different methods, one visual, one pure algebra, but they give us the same result. Now, at first, I would totally recommend doing this on area models until you get the hang of it. Once you get the hang of it, though, I would recommend this second method. All right, so let's call this method 1, the area model, and let's call this method 2. This is the one that I'm going to push in class because you'll see the usefulness of this one when it gets a little bit more complex. So here's some practice problems for you to pause and try along on the video. And let's see if you got the hang of it. Once again, you can always draw this area model to get you going, but take a moment, pause this video, and see if you can follow along and nail these. I'm going to make a follow-up video with the answers to these next three problems, and then I want you to see how well you did. Hope you found that helpful. Remember to pause, rewind, go back to the parts of the video that you need some clarification on. But that's it. Over and out, mathematicians.